Welcome back to the shop and to the channel. We got a new piece of tooling in the shop to take a look at. It's a 6-inch 6-jaw chuck. It's a buck chuck made in the USA. It's not new by any stretch of the imagination, but it looks to be in really good shape, and it's one of those adjust true set chucks. Well, the jaws move really nice and smooth, so that's a bonus. Usually when I get these old chucks, they're either bound up or full of chips and don't like to move. Well, the back plate on this is threaded at 2 1/4 by 8, which is great for the newer South Bend lathe that I have, the one that I'm still restoring, and for like a South Bend Heavy 10. But this won't fit on the lathe that I'm using day to day, which was made in 1942. It has a 1 7/8 by 8 TPI spindle thread. And I'm thinking I might want to make a new backplate for it so I can use it on that older lathe. But before I can do any of that, I want to disassemble the chuck just to make sure that everything is in good condition, that there's nothing broken, and also to get some dimensions on how I would construct a new backplate. And I'll start by removing these 6 socket head cap screws that hold the backplate onto the back of the chuck. Well, this thing was definitely disassembled in the not too recent past because there's anti-seize, there's copper anti-seize on these bolts. And taking a look at the backplate here, it looks to be in pretty decent condition. There are some chips in here, but I would expect to see that no matter the age of any chuck. There's these 4 set screws in the back of the chuck here, and these allow you to adjust the position of the chuck in relationship to the backplate, much like you would adjust a 4-jaw chuck, so that you can get an increased level of repeatable concentricity. And that's a long-winded way of saying if I remove a part from the chuck and I put it back in, unlike a typical 3-jaw chuck, with this chuck, I should be able to get it still back in line with the spindle, and I'll still have that concentricity. Well, I have a ratchet extension in my impact driver that's just about the right size to fit in the pinion, so I can get the jaws removed. Well, I have this on the lowest setting, and it was getting a little bit stuck there, so I think I'd rather finish this off by hand. Again, I don't want to break anything. I don't mind using power tools to speed some things up, but I certainly don't want to overpower something like this to the point where it would potentially crack something or break it. Well, this is not a new chuck by any stretch, but looking at the face of these jaws, they actually look to be in excellent condition. I don't see anything major, no major wear on it. Right, the land on the tip of the jaw is about the same across the entire length, and using a machinist square here, they seem to be still pretty square. So I don't think there's very much wear in this chuck at all, which again is very different than the other chucks that I have for that older lathe. Well, there's 6 more screws here that hold the front of the chuck to the back of it, which also captures the scroll in the pinion. And here's a pro tip for you. These things are a lot easier to disassemble when you remove all 6 of the screws and not just 5 of them. dummy. Well, that only took about 5 minutes to realize that there was still a screw here, and with that one loose, the two halves of this chuck actually come apart very easily. Well, the inside of the back half, again, is in really good shape, as is the pinion. I don't see any excessive wear on it. The grease that's in here looks really clean. None of it's really chunky. So again, I would say someone was probably in this chuck, maybe cleaning it and putting it back together within the last couple of years at most. Well, and before I forget, there's 4 little shoes that are in where those set screws were at, and those are what press up against the back plate for the true adjust. And I'm just going to knock those out here with a nice long punch. Well, I'm going to get all these parts into the parts washer and clean up all this grease. We'll go ahead and re-grease it at some point. But I think in the meantime, I want to think about what is it going to take to make a new back plate for this chuck. Well, since I'm going to be boring and threading 1 7/8 8 TPI internal thread into the new back plate, I need something to test those threads with. I don't have a 1 7/8 by 8 TPI bolt laying around, and it would be better if what I'm testing it with really matches the spindle. So I want to make something that is a facsimile of the spindle on this lathe. So I want to take some measurements here of the lathe spindle just so I can get some, as accurate as I can get dimensions of it. So when I make the spindle plug, whatever you want to call it, that it is as close to this real spindle as possible. Now, it just so happens that I have a 1 to 2 inch thread pitch micrometer, and this is going to be a huge benefit because I can measure the thread pitch here with this, and I can make sure then that the new facsimile of the spindle that I make is the exact same thread pitch. Well, I've already taken all the other measurements that I need, so I can get my chuck back on here and I can get started on making my fake spindle. Well, I have a chunk of 12L14 that I'm going to use for my fake spindle. I really love working with this stuff. It's a leaded alloy, and so it machines really easy and makes really nice chips, and has a really good surface finish. The only downside of using this material, and I really haven't experienced that downside, is you can't weld it because of the leaded content. It doesn't weld. You could try, but it doesn't weld. I'm going to put a center in here because there's just quite a bit of stick out here, and threading, there's generally a good bit of tool pressure, so to avoid any accidents here, I think it'll be much better if I get a live center on the end of this. Well, I'm going to clean up the OD of this piece of material here for the first 1 3/4 or so. There's no specific dimension here. It's not critical. Just want to clean up the surface a bit. Well, with the OD cleaned up, now I want to mark where that back shoulder of the spindle is. Now I can turn this section down to about 1 7/8 so I can get set up for the threading operation. There's a section of the spindle nose that's unthreaded. The threads don't go all the way down to that flat section. So I'm putting a mark here so I know where I'm going to stop the threading operation. I'm also going to turn down this section of the spindle so it's just a little bit less than the 1 7/8. The original that's on the lathe is just a couple of thousandths shy of that. Well, we're just about ready to start the threading operation. I am going to put just a little bit of thread relief here at the end where the thread ends. This is not how the original thread is cut on the spindle, but I think it's a little bit better for me as an amateur hobby machinist to give myself a little bit of leeway here in regards to how I thread this. I'm no A-bomb 79, that's for sure, so I'm going to give myself just a little bit of a crutch here and put some thread relief in. Well, I've got some blue Dicom on the blank here, and I'm running the lathe in back gear nice and slow. I always run a scratch pass. I think it's a safe thing to do. There was one time in which I had a lever set wrong, and that would have really screwed me up had I not noticed it. So we'll take a very light 1/1000th or so deep pass here and check it with the pitch gauge. Well, that's perfect. That's right on 8 TPI, so we can get started on this. We'll take this nice and slow and try not to screw it up. Whenever I'm threading, I put a dial indicator on the back of the tool post because I don't trust the dial on my compound. Right here, I've got it. The mag base for the dial indicator is on the carriage, and so when I pull the cross slide back, it pushes on the dial indicator, and I think that's creating some problems for me. So I need to move it. There's a little bit of room on the cross slide where the mag base will fit. I think there's enough that it should be okay. Well, now I can more accurately keep track of how far I'm advancing the tool on each pass. Had I set this up correctly when I started this, I'd be able to keep track of how far overall the tool is being advanced or has advanced. Because if I know my pitch depth, I should know based on the dial when I've gone in far enough to form a complete thread. Now, I always check before I get to that pitch depth, but it's always a good gauge so you know that you're at least not going too far. Well, I've taken enough passes here. I can check it here with the thread pitch micrometer. I'm starting to get a sharper point. It's not quite fully there, but for a thread pitch, I measured previously 1 inch 791 thousandths, and so that's what I want to match here on this thread. Well, still a little ways to go here, so we'll fire the lathe back up and take some more passes. Well, according to the micrometer, we have hit our target of 1 inch 791 thousandths. So I'm going to grab a faceplate and give this thing a test. Well, that's certainly going on, but it is just a little bit tight. So I think what I want to do is take this back off. I'm going to run a scratch pass, file down those threads, and we'll check this again. Yeah, that's a much nicer fit. I don't think I could be any happier with these threads.
That is perfect.
Well, before I take this thing out of the lathe completely, I want to clean up a little bit more of the OD and also take a little bit of emery and sandpaper to the threads just to make sure there are no lingering burrs on there. Well, I really don't think I could be any happier than how this came out. I don't do a lot of threading on this lathe, and when I'm trying to hit something this exact, it's nice when it actually works out. Well, inside of this chunk of steel is a new backplate for that chuck. And it's not the ideal material, but it's what I have. This is a piece of 4150 that somebody gave me some time ago. It's about 5 inches long, 6 inches in diameter. I'd prefer a piece of cast iron or Durabar, but for me to get a piece from McMaster would be about $60, $70. It's not a ton of money, but it's more than I really wanted to spend right now. I have other priorities in the shop. It's almost the perfect diameter. It might be just a touch larger, which is great because then I can machine off any of the rust that's on the outside of it. The only downside is it's 4150. It's pretty hard, and I know my lathe is going to struggle to machine this. I just need to figure out how to cut, about 1.5 inches, maybe 1.75 inches off of the end of it. Well, I don't have a whole lot of options, at least in this shop. I kind of asked around to see if there's any place local that might be willing to cut off a section for me without charging me anything, and I didn't really get any decent answers, so I'm going to have to resort to using the good old Harbor Freight 4x6 bandsaw. Now, this piece is a bit oversized for it, but oddly enough, when I clamp it in the bandsaw vise, it actually grabs it. So I think I'm just going to see how far I can get with this. I don't know how far the saw is going to be able to reach into this piece. I'm certain it's not going to get halfway through, so I might need to have to rotate this thing a number of times. It very well may leave a centerpiece that I'll have to figure out then how to deal with, but I guess as of now we'll just have to sit back and watch and see how far it'll go. Well, I'm getting to the point where I'm going to have to stop the saw, at least at some point. I'm watching this thing from the side, and I just kind of feel like if there was an extra quarter of an inch where those rollers at the top were maybe a quarter of an inch further toward the front of the bandsaw, that this thing might actually be able to lever all the way over and maybe get, at least 2/3 of the way, maybe all the way through. But looking at this, I'm pretty sure those bearings are going to hit this piece of material before it would have that opportunity to go all the way over. Well, I'm using this popsicle stick just to see how close that bearing is, and sure enough, this is not going to be able to make it past it. So I'm going to have to stop the cut here, and then I guess just rotate this piece and try to line it back up with the existing saw kerf. Yeah, this is going to take a while. I'm pretty sure I'm going to have to rotate this piece of material at least 3, probably 4 times in order to get a cut all the way around at least the circumference. So I won't bore you with all of that, so I'll bring you back when we get a little bit closer to that goal. Well, I've rotated this piece a few times here, and we're getting close to where this current cut is going to match up with the start. I think it got a little off kilter, but I don't think it'll be by much. I'm using some compressed air here just to keep the field clear so I can see when we get close. Well, there's a little bit of an offset here between the last cut and the first, but I think we'll be able to manage that. It's going to make that surface not very flat. It's going to take some time to machine it, but, it is what it is, and I have what I have. Well, as suspected, that cut didn't go all the way through, so we'll break out the Artisan Makes 3000 Super Cut Saw here and finish it off the rest of the way, or at least attempt to finish it off the rest of the way by hand. Well, this absolutely sucks. I don't want to do this anymore. I'm not making very much progress. So I'm going to try something here with the bandsaw and see if I can't get this thing to cut a little bit deeper. Well, I made a slight modification to the bandsaw. I actually pulled off the back jaw of the vise. I don't know why it's positioned where it's at. I think it was pushed back another inch, maybe even 2. There'd still be plenty of room for the saw to clear, and it would gain that much in capacity. It might be a future modification to this saw. But with that back piece out of the way, I've got now a couple more inches in capacity on this saw. And I think that if I, wedge this piece of angle back here, I can get the front half of the vise to grip onto this, and I think I can cut this thing all the way through.
The next day.
Well, that definitely wasn't easy. Was it worth it? We'll find out when this thing is finished, but I hope I never need to do that again. Well, that took quite a while. Hours, actually, between rotating it, recutting it, etc. Probably 2 hours maybe into this, maybe more. Quite frankly, I lost track of the time. But it's done, so now I can move on to the next step. It's going to take some work machining off some of the mess that the bandsaw left behind. Well, the next thing on the agenda is to chuck this up in the lathe and clean it up and bore and thread a hole. But I have run out of time in the shop for this week. So unfortunately, that is going to have to wait for the next video. Well, if you like the video, give it a thumbs up. Leave me a comment down below. Let me know what you would do differently. I really do appreciate all of you that have subscribed to the channel, and if you're not a subscriber, hit that subscribe button. It costs you nothing, and if you click the bell icon, you'll know when I publish another video. And if you'd like to support the channel through PayPal or Patreon, there's links down in the description on how to do that. Thanks for watching, and we'll see you on the next one.